We turn now to case study 1.4, and this involves the application of the scientific method. And we're going to use the UV catastrophe as the central example. But we should point out that science has two fundamental objectives. First is to explain natural phenomena and to use the understanding of such phenomena to predict future events. And we begin with the Greeks. Aristotle, as we have learned in the core of this chapter, was profoundly important for the development of modern science. And Aristotle brought deductive reasoning to the forefront of disciplined thought. Deductive reasoning is fairly straightforward. It says, for example, if A is equal to B and B is equal to C, then A is equal to C. So deduction is a category of logic, but it turns out it's not sufficient for the advancement of scientific knowledge, and Aristotle recognized this. 2,000 years later, the structure of the scientific method began to explicitly emerge in the 1600s. Galileo, Francis Bacon, Robert Boyle, as we've seen in the core of the chapter, were very important in the development of the scientific method. In the 18th and 19th century, David Hume, Thomas Young, Isaac Newton, and Sadi Carnot advanced the sophistication of the scientific method. A central tenet of the scientific method is that observations begin the process, and observations of natural phenomena or events constitutes the initiation of a chain of logic that in turn develops a strategy for a concise, coherent, and testable theoretical structure. So the observations lead then to a hypothesis. Now comes the approach that uses the logic of inductive reasoning, wherein with no initial assumptions, a series of observations have been made such that a pattern begins to develop, leading to a generalization, a law that explains the ensemble of observations. So we start with the observations, we create a hypothesis, and that hypothesis leads to a refinement of experiments. And one of the most famous examples of this was the work of Copernicus, 1473 to 1543, in which he made extensive observations that proved that the Earth, along with the other planets, revolved around the sun rather than the belief of the day that all astronomical bodies rotated about the Earth. Now, it was very difficult for Copernicus to convince contemporaries that this was in fact the case. In fact, he ran into serious objections because it also violated some fundamental tenets of religion at the time. But Copernicus laid the groundwork for this development of linking observations of planetary motion, with a hypothesis that the planets are circling the sun rather than the Earth, refined the experiments, more and more planets, more and more observations, tuning or revising the hypothesis. And so this linkage then was set up between sophisticated experimental strategy and the development of a theory. And as the sophistication of the experimental approach improved, so too did the strength of the theory that was representing the explanation for why those events were occurring.